Muted.
Good morning, everybody. Thank you for attending this month's webinar. Today we'll be going over our topic of Modbus applications. Here's our agenda for today. First, we'll give you a brief overview of Modbus. Then we'll go over a few of Modbus's limitations, some Modbus troubleshooting support, and some common applications and solutions for Modbus applications. ICP-DOS was established in 1993. Our headquarters is in Hsinchu, Taiwan, and ICP-DOS USA was launched in 2001 to support the North and South American markets. Our company's products are RoHS compliant, we're a Microsoft embedded partner, and our products are ISO 9001 certified. About Modbus. Here's some details about Modbus. Modbus was developed in 1979 by IKAN, now owned by Schneider Electric. Modbus is an open source and royalty-free to use. It's the most commonly used protocol for industrial applications. It's a serial-based protocol communicable normally over RS-485, where you can support up to 255 devices that can be daisy-chained along a single bus. Modbus TCP was developed in 1999. It's similar in structure to Modbus RTU, except it's implemented over an Ethernet network. Larger networks are possible due to Ethernet communication being faster and more easily expandable. Devices traditionally have their own unique IP address to differentiate, as opposed to different node IDs in Modbus RTU. Modbus RTU has some limitations, though. Each slave device along the RS-485 must be daisy-chained. Serial communication is also slow. The network must be implemented due to the distance and wiring limitations, along with baud rate and other parameters to severely limit the maximum distance. It's not easily modified because wiring is daisy-chained, and it's better for smaller applications. Here's a comparison between RS-485, which standardly is used for Modbus, versus some other bus types. It's much slower than CAN bus and much slower than Profibus. But when you compare the number of nodes and the implementation, there's quite a few downfalls for using Modbus and RS-485. But because it's the most commonly used protocol out there, we have a few solutions which can be used to help alleviate some of these problems. The first project we're going to go over is our Modbus RTU to Modbus TCP gateways. This would be our TGW 700 series, specifically our TGW 715, which is our most popular item. It's a Modbus TCP to Modbus RTU gateway. Let's see, it will accept communication either way from either one Modbus RTU master to one Modbus TCP slave device, or if implemented the other way, where you have a Modbus TCP master, you can have multiple masters and communicate to the same RS-485 bus, which can communicate to up to 250 slave devices. Some common problems and reasons to use the gateway would be you have multiple masters that you need to communicate to a set of slave devices. So you would use Modbus TCP, which allows for multiple master devices, and you can communicate to a single set of slave devices communicable over the RS-485 bus of the TGW. If you have Modbus RTU devices that are scattered throughout a building or complex where there's an existing Ethernet network, they can easily be added. And when you have Modbus RTU devices which are at remote locations, you can connect through the internet using TGW series. Here's an overview of the application. So you have a PC, which is a Modbus master in this case, communicating to two different buses. The devices connected to COM1 would be referenced with the IP address of the TGW plus port 502, and you can have up to 255 devices on that bus. And at the bottom, there's a COM2, which would be referenced by the IP address and port 503 of the TGW, and you can communicate to up to 255 devices along that bus. So the devices along the two COM ports are RS-485, which can be Modbus RTU or Modbus ASCII, and your master devices in this case must be connected via Modbus TCP. The next module or solution we have is our Modbus Sharer. This is great for a situation where you have two Modbus RTU masters and you must communicate to a single set of Modbus slave devices along the RS-485 bus. So there's two incoming RS-485 ports and one slave port. What this module will do is it will buffer the second command that comes through until the first command is either completed or timed out. And then we'll send the second command to the slave devices along the RS-485 bus. You also have the ability to do different baud rates and different parity along each RS-485 bus. And you can do Modbus RTU to Modbus ASCII conversion as well. Here's the example with two Modbus RTU masters. So connected to COM1 and COM2 would be two different Modbus RTU master devices. They can be the same parity and communication parameters or different, and you can communicate to the same set of Modbus RTU devices along the RS-485 bus. This would be our TSH735 in this case, with all three ports being RS-485. We also have a few different communication combinations if you have RS-232 instead of RS-485 on one of the buses. This next slide just shows our TSH725 in this case. What this one does is it has two RS-485 ports, and each side has a different baud rate and parity option. So you can set those within the web interface for configuration of the module, and you can communicate RS-485 or Modbus ASCII from either side to the other device. Here's the example with Modbus RTU to Modbus ASCII conversion. The configuration allows you to communicate from a PLC that is communicating Modbus ASCII to one or multiple slaves along the RS-232 or 485 port via Modbus RTU. This is great for situations where you have a device which is fixed to one protocol but must be converted to a second to be, I guess, common to other devices on the network. And it's important to pick a TSH module with two COM ports for this, whereas the sharing application requires a 3. So in the part number of TSH72, the 2 stands for 2 ports, and a 3 in that place would be 3 communication ports. For debugging Modbus RTU, we have this slide which shows our TM7561 connected to the RS-485 bus, and this is used to debug and test Modbus RTU communication. Here's the way that we standardly use here for debugging communication. So we have a Modbus RTU master and slave devices not communicating properly. To debug these, we connect an RS-485 converter from a PC and send commands to the slave devices to verify that the command and response is correct and communication is possible, including signal strength. By adding a serial port to the PC, we can communicate to these devices. Here's a picture of two of our devices, the TM7561, which is a USB to RS485 converter, and we have our i7561U, which is our Windows 10 version of our old i7561. This one is a USB to RS422, 232, and 485 communication. So you can communicate to one of the three at one time. But it has all three options, whereas the TM module is only RS485 on the output. For debugging, we use Modbus RTU simulators to individually connect to the slave devices and to the masters. So you would, in this case, set up a TM7561 connected to a PC and send commands and verify responses to your Modbus RTU slave devices. And then, if you don't find the problem there, you can set up the PC as a Modbus slave device using a slave simulator, and from your Modbus RTU master device, send and verify responses and communication parameters from the master to the slave devices. In this case, using a simulator, so you can see where the problem is. If you still can't find the problem, then there's other techniques as well. But this is the easy way to verify communication without using a oscilloscope or something. For RS485, bias voltage is very important, and termination resistors will help improve the square wave communication. Since RS485 is communicable, is a serial protocol, it's essentially a series of high signals and low signals in the form of square wave. To get the best square waves, you want to use proper wiring and make sure that your bias voltage is strong enough to give a clear signal. If the square wave is of insufficient amplitude, the signal will either be not read properly or could be distorted where it's possibly read or possibly not, so it's unstable. For these situations, we have a couple of solutions. The RS485 bias voltage and termination resistor modules we have are a great solution. The SG785 and the TM-SG4 can provide the bias voltage to these modules and termination resistors. So they'll be used for pull and pull high resistors, or pull high and pull low resistors for making the signal clearer at 5 volts. And it will add termination resistors for proper wiring of the RS485 bus. Wiring hubs and repeaters are also great for both extending the signal and branching off. Here's a brief overview. RS485 is traditionally communicable using a twisted pair of copper wires. The maximum bus length is standardly defined as 4,000 feet. This distance can be severely limited by higher baud rates or improper wiring or even branching off. Many factors such as baud rate, wire type, and termination resistor can cause signal loss along the RS485. In this instance, a repeater can be added in the middle to read and retransmit the RS485 signal at a stronger rate. So as at a point in the middle of the bus where the signal strength is getting low, you can add a repeater and it can read in and rebroadcast the RS485 signal at the full 5 volt potential. And for RS485 wiring also allows for daisy chaining multiple devices along a single bus. It does not allow for branching in different directions. In this case, a wiring hub can be used. I'll give you some example pictures in a second. Here's a picture of our I-7513 architecture. So it's got an incoming RS485 bus signal from the master device, and you can branch off in 3 different directions. All 3 of these branches would be considered along the same bus. Because the wiring hub will send out everything from the master to the 3 buses and read in the responses from any of the 3 buses and send it to the RS485 bus. This allows for multiple directions and also acts as a repeater for larger networks. This next example is a little bit more complicated. It adds in like a few other modules and branches. So for larger networks, it can be used like this, where the I-7513 will allow you to branch off in many directions, but the I-7510 can be used to increase the distance so you can communicate at higher baud rates to all nodes. So all of these would be considered two COM ports. COM 1 at the top starts off as RS-232, and the signal is converted to RS-45 and branched off into 3 different directions, and is branched off even more by a second I-7514U. At the bottom, the communication starts off as a USB connection going to our I-7563, branching off into 3 branches, and then one of the branches branches off even further using the 7513, and the 7510 reads in and repeats the signal, so you can increase the signal strength and increase the bus length, and more nodes can get the communication. As you can see, RS-45 does have many limitations, which makes it so wiring hubs and repeaters can be very useful in these applications. The next product we're going to go over is our Modbus data concentrator. This would be used for when you have too many slave devices for the master. Because RS-45 is serial-based, or Modbus RTU rather, is a serial-based communication, the limitations are based on baud rate, response times, and communication distance. In this instance, if you use one master and communicate to many different slave devices, the response can be slow. By using a Modbus data concentrator, what it does is it will communicate and pull data from multiple slave devices, combine it into a shared memory of this module, and will be able to be pulled in a single pull from a Modbus master. I'll show you the architecture in a second. So what happens is the slave devices connected by RS-232 or RS-45 are pulled specifically in a specific order by the MDC-711, and your Modbus master would pull it for data from multiple slave devices, thus saving additional polling and communication time by getting multiple slave devices data in one poll. And Modbus TCP is also faster. So this will speed up the data acquisition or communication to the slave devices. For displaying Modbus data, sometimes all you need to do is give a visual display which will show a nice HMI or show the data in general. Like for instance, using our VPD143H, which is IP65, you can use it to display Modbus values. The TPD430H shown in this picture is 4.3 inches. We have smaller ones at 2.8 inches and larger ones up to 7 inches. And our IKAN are large digit displays, which can be used for displaying Modbus values to a larger audience. Here's an example of what our IKAN would do. So it is programmed with a series of messages, and within those messages you can include Modbus data acquired from Modbus RTU or TCP slaves into the messages. So in this example, output voltage would be the message, and then the variable would be the plus 2.35 volts from one of the Modbus RTU slaves, or you can use this with like a temperature meter to just say the temperature inside is, and then use the Modbus RTU variable as a temperature. And you can use this for like airports or factory or production environments. The next slide shows our Modbus RTU communication to our TPD and VPD series. These are both touchscreen displays with programmable logic and the ability to communicate to using Ethernet or RS-45, depending on the model, to Modbus RTU, Modbus TCP, or DAQ slave devices. The VPD series has the IP65 waterproof housing, and they both have buzzers which can be used for audible signals as well. And these come in 2.8, 3.5, and 7-inch screens. And just choose the model based on what type of communication you want to do. Next, we will briefly go over our Modbus data acquisition modules. These would be used in situations where you have Modbus data that you want to retrieve and do data acquisition or add it to a current PLC which has a Modbus communication card. The ET series are our Modbus TCP remote data acquisition modules. The M7000 are Modbus RTU data acquisition modules. These would be used for serial applications. Our TM module are smaller versions of our Modbus RTU with less I/O count. But if you have small applications where you have a few I/O in either various locations or just a few I/O in general, the TM series may be a good solution for you. And our newest series, the ET7200, is similar to our ET7000 series, except it's got 2 Ethernet ports. So it allows daisy chaining of multiple Ethernet devices, and if the module is off, data is still passed through to the second Ethernet port so that you can save the number of Ethernet ports from your switch. So from your Ethernet switch, you'll have one connected to the switch, and then you can daisy chain multiple ET modules along that to the same port. The next solution would be if you have multiple, or say you have an existing Modbus network, you can add one of many Fieldbus devices. Using other protocols will sometimes be other equipment that are added after the fact. You can use gateways to communicate from any of these Fieldbus devices and convert the signal to Modbus, or sometimes vice versa. We have a selection of all these different protocols from CAN bus, DeviceNet, CAN Open, J1939, MBus, Profibus, which is very popular, Profinet, which is the Ethernet version of Profibus, EtherCAT, Ethernet IP, used very much by Alan Bradley. BACnet and HART communication is possible, and our gateways will help you convert the signal to Modbus so you can implement them to like a SCADA system or PLC where Modbus communication is already happening. Some industries and applications which all these solutions are used are pretty much the full gambit, everything from industrial automation and SCADA to solar, wind power, manufacturing, waste treatment, data processing, data logging, laboratories. All of these applications can communicate Modbus and are very popular for Modbus communication in general. Let's see. If anyone has any questions about these products or additional products, we'd be happy to answer them. If you want, you can also contact us after this webinar if you want to go over an application. Our contact information is here. You can follow us on Twitter. We have a YouTube channel, Facebook, and Pinterest. Let's see. If anyone has any questions, please type them in the chat box. Let's see. I do see. Let me expand this so I can see the question. Okay, what advantages and disadvantages does Modbus TCP have over Modbus RTU? Well, let's see. Modbus RTU, because it's serial protocol, has many limitations based on signal strength and slowness due to wiring. Modbus TCP uses standard Ethernet cables and standard switches. It's oftentimes much easier to expand Modbus TCP networks. If your application is small or you only have a few slave devices, Modbus RTU is perfectly suited. It's heavily used in like conveyor applications. For Modbus TCP communication, you can spread it out and use Ethernet switches or an existing Ethernet network. So for instance, if you had a building with temperature sensors in different rooms or different floors, that would be more easily implemented over Modbus TCP. If you had like a single assembly line where everything's going along the same conveyor, a Modbus RTU network would be, I guess, perfectly fine, or you can use Modbus TCP. The next question, can you use the same slave address on two devices, but with each connected to COM1 and COM2? Let's see, we have a feature in our TGW which allows for virtual IDs. So with that feature, yes, you can, but traditional, well actually, let me see, was that with our same? Let's see, you can only have one address, or each address must be unique along a single bus. But if you have multiple COM ports, in this case with COM1 and COM2, I believe you're talking about our TGW modules like a 725. A device is connected to the IP address and port 502 of COM1 would be a different bus than the IP address and port 503. So in this case, yes, you can have multiple devices with the same slave ID along each bus because they're differentiated by the IP address and port number in this case. If it was for a different module, please let me know and I'll revise the answer. The next question, let's see, I have an issue where a VFD drive is affecting my Modbus data. Do you have any device that I can use to mitigate the problem? Let's see. A VFD drive is probably giving you noise. So using something like pull-high, pull-low resistors can sometimes improve the signal. Ideally, you'd want to, wire around a heavy noise source. If it's not possible, you want to, I guess, maximize the signal strength, insulate the wires from noise, and possibly use like a repeater to read in and rebroadcast the signal after the VFD to make sure, assuming that it comes through clearly, maybe marginally clearly, but at least clearly past the noise source. Let's see, next question. Do these devices work with BACnet networks? We do have Modbus to BACnet converters. So using a gateway, like our BACnet IP gateways, and converting to Modbus, yes, you can. Let's see, we can go over that situation. Let's see, in our BACnet category, let me get a website going. Let me find you the model number really quick. Okay, let's see. Let me bring up a web browser over here. Okay, so in our gateway converters, we want to go Fieldbus, BACnet. Here's a link to our BACnet gateways. We have two different choices, our GW5492 and GW5493, our BACnet to Modbus RTU gateway. and BACnet to Modbus. I think this should be TCP. Let's see. Yeah, this should be Modbus TCP. So we have Modbus RTU and Modbus TCP solutions for that. We'll get that fixed on our website in the table. The next question, does your remote data acquisition use analog signals like 4 to 20 milliamp or require Modbus devices? We do have Modbus RTU and Modbus TCP data acquisition modules which can read in 4 to 20 milliamp signals. Let me give you an example. For a Modbus RTU, it would be our M7017 module. Actually, let's do the C version, M7017C version. This one has the resistors built in to read in the signal with 4 to 20 milliamp. It does not do voltage, but it does have the resistor so you can wire current directly to the terminals. If you need a Modbus TCP data acquisition, it would be our ET7017 series. Let's see, the next question. And we have many different combinations, so if you need less channels, more channels, or something else, please feel free to give us a call after, and we'll go over a more general solution for you. Next question, do these devices work with, okay, that's been asked before concerning BACnet. Let's see, that's all the questions I see right now. If anyone has any last minute questions, please type them in now. Our next webinar will be in March. Let's see, the topic will be announced in the newsletter. If you do have any topics that you'd like us to go over, please feel free to email us and suggest it. And if you have any Modbus applications or applications in general that we can help with, please feel free to contact us. Again, let me give you the slide with our contact information. So if you have any questions or we can help with this, please let us know. This presentation will be added to our website probably within the next 2-3 days. And we look forward to hearing from you with any questions or comments about this webinar or suggestions for future webinars. I don't see any more questions, so thank you all for attending, and we'll see you next month.